Hey everyone, I'm McCabe Levingood, and today I'm going to walk you through the Lab 3 on circuits. The main purpose of this lab is to predict the behavior of circuits containing resistors in series and parallel circuits, use multimeters to measure the actual values of conventional current and potential differences in the circuits, and then to examine the behavior of ohmic resistors and capacitors. For today's lab, we are going to need to know some important physics concepts, mostly the node rule and the loop rule. The node rule is that the current going into a branch in the circuit is equivalent to the current going out. So I1 plus I2 minus I3 equals 0. This is saying that I1 plus I2 going in equals I3 going out. And then also we have the loop rule, which states that the delta V in a closed loop equals 0. So the change in voltage from a capacitor and the change in voltage from a resistor in a closed loop equals 0 is essentially what that is saying. And then also we have some equations to the left. That's V equals IR, and then the electron current, and then the conventional current. Now we're getting into the experimental portion of the lab. First we did a prediction, and using V equals IR, I found that in this particular scenario, I would be equivalent to 0.02 amps. And then we actually created our own circuit. So in the first scenario, the ammeter reading for I1 was 19.3 milliamps, and I2, it was 19.5 milliamps. Then we reversed the direction of the current, and the ammeter reading was then 19.4 milliamps for I1, and then I2 was 19.5 milliamps. So in the last scenario, we were using two ammeters, and in this scenario, we're converting one of them to a voltmeter. So I1 is now reading 3 volts, and then I2 is reading 19.7 milliamps. And then we calculated, we collected the potential differences across different circuit elements. So in the 47 ohm resistor, the voltage was negative 1.934, and then in the 100 ohm resistor, it was negative 0.931 volts, and then the sum of that was negative 2.865, and the measured voltage should be negative 3. However, our experimental data showed a voltage of negative 2.865, like I just said, and this is likely due to the resistance from wires. Here is a graphical representation of the voltage drop as you can see, across the 47 ohm resistor. I put a little label 1.934, and then 0.931 for the 100 ohm resistor. This is just a graphical representation of what I stated in the last slide about the voltage drop. Now moving on, just to go over some things in the lab, the current remains constant even when the voltmeter is attached to the circuit, and the ammeter reading across the 100 ohm resistor is 19.7 amps. However, replacing the voltmeter with an ammeter in parallel with the 100 ohm resistor causes the current through the other ammeter to read about 26 milliamps. And then to the right, I have some calculations that we did to calculate the resistance of each circuit element. As you can see, we're just, again, using V equals IR, but rearranged. In this portion of the lab, we're going to be going over RC circuits. To the left, I have some equations and a little visual representation of what was going on, and then also some observations. So as the capacitor is charging over time, the bulb gets to be less and less bright. This is because there is a buildup of charge on the capacitor over time, and that is opposing the current, which causes the brightness to decrease and dim. And then the capacitor stores charge and is able to provide energy to the light bulb. And when we used the 20 ohm resistor, we found that the bulb stayed lit for longer and the light was shining brighter. And lastly, the capacitor took 41 seconds to charge and 53 seconds to discharge. I thought I would share some videos from the lab. All of these essentially look the same. It's just the capacitor charging and discharging, and then a visual representation of that process being the light bulb lighting up and then dimming. If the capacitor was being charged in a circuit without a resistor, the situation would be modeled using this equation, and RC would be equal to 0, meaning that theoretically the capacitor would charge instantaneously. This cannot actually occur because there would be resistance from the wires and the battery. Thank you.